Okay, in this video, we're going to go take a look at how we would ohm out or electrically check a variety of ignition coils. This is a critical skill to be able to check out, hey, is a coil good or bad? We should be able to check it out electrically and very quickly electrically with some regular old things. We'll use our good old fluke meter here. Yes, we'll bring that up, and we'll do our fluke, and we will show you how to go check both primary and secondary windings in a variety of coils. First of all, and if you've looked at a video pad, let's describe what we're going to do. If we've got a coil, and we'll take an old school coil that I have here, and we'll draw an old school coil. Inside are two sets of windings. Okay, how does this thing work? Well, it works like any other component. What do we have to have? Power and a ground. So we're going to have a battery plus on this, and we're going to have a negative on this. And what we're going to have around this outside is a series of windings. Now these are fairly coarse windings that go around, and they actually don't go around this circle. They would go around in a circle like this, but I'm going to just demonstrate that. And those would be considered my primary windings. And the primary windings job is to make magnetism. And what its job is, we are going to make electromagnet out of this thing. So we're going to put 12 volts in. And then on the other side, we've got to have it grounded out. And that ground is going to go through a switch of some sort to a ground. That ground might be a set of points. It might be a transistor inside a module. It might be inside the PCM. Somewhere there's going to be power and a ground. And when we apply power and a ground to that primary winding, it's going to start producing magnetism. And we're going to have some large magnetic lines of force that are going to be generated around this. So, not a problem. And what we do is we just make a bunch of windings in there to go, and the primary job is to make magnetism. Now, also inside of a coil is a set of secondary windings. Those secondary windings are a very fine winding. And compared to how many loops this would have around, typically a secondary winding is going to be at least 100 times more, which means the wire has to be much smaller. That wire also is going to have a lot more resistance because there's a lot more of it. And that secondary winding is going to come all the way down, and just like anything else, it's got to have a positive and a ground. And we'll just say that positive is going to come all the way up, and that positive comes out the center of the coil. And of course it needs power and a ground, so we're going to have ground over here, and this is actually this is where the sparks are made. So the secondary winding is where the sparks are made. The high voltage that is going to jump our spark plugs. We're going to have approximately 12 volts coming into this point, although we'll talk later about voltage spike, and that actually gets rocked up to sometimes a couple hundred volts. And what we do is we turn on that primary current, and when it stops, it collapses inward very quickly. How fast? Well, speed of light. So that's pretty darn fast. And how do we make electricity? Well, we can make electricity. One of the ways to do it is have a winding and move a magnetic field through it. So as those magnetic fields collapse, they break upon these windings right here on the secondary windings. And because we have magnetism falling across that, it induces and makes a voltage coming out of there. Typically any voltage that we're going to come out of our coil, an old school coil might make 15,000 volts. Today's coils make upward of 45,000 volts will jump out of there, produced when that magnetic field collapses. So we're going to have to do some checks on these things. And the checks we're going to have to do is we're going to have to check the resistance of those windings. We're going to do it through a variety of coils. Typically, we're going to put an ohm meter across positive and negative. Let's go positive and negative this way. And we're going to ohm the resistance of that winding. And it's going to have a specification and a varying specification depending upon that type of coil. Then the second thing we're going to have to do is we're going to have to measure the resistance of these secondary windings. Those secondary windings are going to have many more windings and be much higher resistance than these low resistance primary windings. The last thing we want to do is none of these windings, none of this electricity we want grounded to a case. That would be bad. So if this primary winding was shorted to the case, that would short out that current and not allow that to build any magnetic field. If this is shorted to the case as well, I'm going to take that high voltage and it's going to get bled off to ground through the case on these. So we're going to also check for continuity, or in really the case of lack of continuity to that case. So let's go check a variety of coils. Let's start with the first one. First one is an old school coil that we have. You might have seen this on an old vehicle, an old, what we called an oil-filled coil. And this one is off an old points setup. It's an old, what we call yellow top from Ford. These are all Ford coils. And like I said, with everything, and they usually say everything works on power on a ground. Well, they even tell us which one is which. If we look real close right here, it says on this terminal, battery. And on this one, may not be able to pick that up real good, but it says dist, distributor. This actually would be the ground would go to the distributor side. And of course, inside is that high tension where that coil wire would go inside. And there is a terminal way down in there. And there is, somewhere in there, there is a terminal. There we go. And that terminal is what that spark plug wire connects to go to the distributor cap on a distributor type system. So what do we got to do? Let's ohm this baby out and see what we get. I'll set up my ohm meter. We'll double check my ohm meter here. Oh well. And we're going to take a couple of leads that I have and jump them together just to double check my setup on this thing. And it settles down to, I got about 1/10 of the ohm between my clamps and all that, which isn't a big deal. So what I'm going to do is, the first thing we're going to do is we're going to ohm out that primary winding in this. So it doesn't matter which way we hook it. We just got to go to power and ground. Doesn't matter which way we hook up an ohm meter. So we go look at this thing, and the resistance on this looks like 1.6 ohms, which is typical of a regular old type coil that this had. That is actually relatively high resistance, but in an old style coil, what we call an oil-filled coil like that, that's atypical. Now we also have to remember to measure that secondary resistance. Now, interestingly, it really doesn't matter which terminal we go to on this. We can go from the negative, we'll catch this. But if we go from the positive, it's going to add in this resistance into that circuit. And this resistance was relatively small. It was only 1.5 ohms. Well, let's go look at what this resistance is and what the difference is between measuring between our battery and our negative. We'll do it the right way first, and we'll go to the negative. I don't have a probe that's going to go that deep, so I'm just going to put a screw in this thing, and we'll go to the center, and we're going to see what the resistance is. Typically it's about 10,000 ohms. Okay, well, this particular coil has almost 23,000 ohms. Very high resistance in that secondary winding. That's probably why it's sitting on my shelf and probably should be thrown away. I think the specification for this coil is about 10,000 ohms. So this has very high resistance in those secondary windings. Okay, could be a partial break in these things, and it's going through. But anyway, that's or through the terminal itself. That's very high resistance. So let's compare another coil, and we'll take that. So there was a primary and secondary, and we're going to do the last check. And the last check we have to do is see if it's grounded to the case. And when I ground it to the case, it says OL. Okay, I have no windings grounded to the case. That is actually very good. So I suspect this coil is bad because it's got high resistance. I'm going to set that one aside. Let's grab another one. This one right here looks very similar, although this one was about the same era, a little bit newer. And let's ohm this one out. So we'll do the same thing. We'll check our primary resistance. Put that on, and this one looks like it's got a little bit more primary resistance, 1.9. I'd have to look up that coil, but it's in the wheelhouse for a coil like that. Now we have to go check the secondary resistance. And here's my positive and my negative, and I'll go from the negative all the way to the center, and let's see what this one with that secondary winding, that black winding that I show there. And this one is about 11,000 ohms, which is about right. I would expect about 10 or 11,000 ohms in a secondary winding. That seems about normal. So, okay, here's some old school coils. Well, let's start going a little more newer. Later we went to electronic ignitions and we got rid of oil-filled coils. And we went to this style coil. In our books, they call this an E-core coil. The reason they call it an E-core is because there is metal laminations all the way around the outside. And it actually has a piece of metal that goes all the way up through the center. This is hollow. The coil is a coil of windings. And then it has another one that comes from the other side. And if I break these little tabs loose on the side, takes this whole thing out, it actually separates out, and it looks like the shape of an E. So it's got metal that comes in an E in this direction there. And the purpose of that is to metal and laminations of metal put in strips like that intensify a magnetic field. So basically, it makes this coil have much more magnetism and intensifies that magnetism in this style of coil than the old round style coil that we have. So it's a better coil. This is actually the ones I use to type my work on my race car, and we're very, very popular. Okay, well, it's the same as any other coil. What do I got to have? We got to have primary windings and secondary windings. Well, if we take a good look at this, I'll put a little flashlight in here, and we'll go look at, here's my primary connections. And if you look real close, down in the bottom, actually you can see they're marked. Positive to the left as you're looking at this, and negative to the right. So my positive will be hooked somewhere to my ignition switch eventually, would be the on-off, and the negative would go to the triggering, probably to an ignition module. Okay, and then I've got, of course, my secondary winding comes out right here. I've got my spark plug, my coil wire would clip on there. So we're going to ohm this thing out. Now these had power, could take a lot more current. And what we saw, to get more voltage out of this style of coil, it's no mystery, we need to make more magnetism. So how do we make more magnetism? We lower the resistance of the windings in the coil, in the primary. So we're going to run a lower primary resistance we're going to expect in this. And what that's going to do is make more current flow through. And more current means more magnetism. Oh, cool. Okay, so let's go look at the resistance of this one through the primary. Half an ohm, 0.5. Wow, that's 3 times less than those other ones. That means it's going to pull 3 times the current. And these coils pull about 10 amps, 10 to 15 amps. Some of the other ones will go up as high as 20 amps. So that means it makes a lot of current flow, which means a lot of magnetism. And when that magnetism breaks down, it means it makes more voltage jump out of this. These particular coils can make about 40 to 45,000 volts coming out. A lot more than those round coils. Those round coils pretty much top out at about 20,000, 15, 20,000, maybe 25 on a good day. So now we got to check the secondary windings on this one. It's real simple. We go to negative and we go to the center terminal and we'll hook it up. Really doesn't matter if it's positive or negative. And this one is your typical, what we call E-core coil. And the resistance on this one looks like it's just about 8,000 ohms, 7.98K, which is very typical. 7 to 9,000 is right in the wheelhouse for this style of coil. So the secondary windings look good on this one. And then we're going to check to make sure none of these are arced out. So we're going to do it to any of the primary. We're going to put the secondary windings and see if there's any continuity to the case. And that says no, which is good. We don't want our spark windings, if we put them on there, grounded out. And we don't want any of these grounded out. So we can just grab any one of these primaries. Doesn't matter which one, because we already said they're connected to each other. And that one also gets OL, so that gets the nod. So this coil checks out relatively good. There are some problems with this style of coil, though. Problems we ran into this style of coil is these things put out such voltage that and it was surrounded by metal on the outside. A lot of times they had this very close gap along the side here. You can see it where the flashlight looks. Very close gap to the side, and sometimes the magnetic field would get so strong it would actually burn a hole right in the middle of this coil insulation, this epoxy, and it would jump an arc all the way over to the side. We would spray these down with typically soapy water, and you would see an arc, or a lot of times we would inspect this style of coil and look for a burn spot right in there. If we saw a burn spot, typically we would spray it down with a little bit of soapy water as a better conductor than just regular water. And that would, and all of a sudden, if it started arcing in there, we're seeing any kind of voltage bleed off, we would put a new coil on it. We also will do coil inspections for what we call carbon tracking, which is carbon tracking is when it jumps an arc all the way down. It'll actually cut a line and make solid carbon out of it, and it tends to want to jump to a ground from there. So I don't see any carbon arcing on this one through the terminal. That looks good. Now we'll go to the next evolution of the coil. And within Ford Motor Company, you might have seen ones like this. This kind of coil was one that we used on waste spark. So I'm going to ask a question of you of how many coils do you see? Well, if you think the answer is 4, well, you're off. This actually is just 2 coils. And these 2 coils are separated in the middle. And these 2 are 1 coil. And these 2 are 1 coil, are shared together. This one is used in systems that we call waste spark. And this actually will say what cylinders. On some of these it'd be 2 and 3, and on the partner cylinder would be 5 and 8. and this one 6 and 7 and all that. So anyway, we actually have 2 coils built into one coil pack, as we call it. So as we look at coils, we have to say, what makes it work? Well, I hope you're with me and you've heard the mantra long enough that you always say, power and a ground. And that's exactly right. Okay, well, let's go look at this thing. Well, I've got 3 wires. Guess what? These things are ground side switched, and it's going to be ground side switched by an ignition module or a PCM. And here's how it works. Guess what? Does it make sense to put 2 power wires? They can share the same one. They're not firing at the same time. So what I can do is put 1 power wire in the center and an individual ground for each coil. So I'm going to have 1 primary winding through 2 of these for 1 coil and the other 2 for the other coil. Well, let's ohm this thing out. Okay, so pretty simple. Well, let's go take a look at the primary. And the primary on here, we've got a hookup. And we'll just go from one center terminal to the other. I'll hook up my alligator clips there. Flexi probes would be better, but this is what I got at home. And we go look at that, and what's our ohms reading? 0.6 ohms. Hey, that's pretty much the same as what this coil was. And you're absolutely right. It's really based the same as a coil like that, the same primary winding. So we go look at this thing, it's got 0.6. Well, let's go measure the other coil and see how that one comes out. So we're going to go measure the other side. And we measure that side, and that side comes down to 0.5. A little less resistance, but pretty much identical. And 0.5, 0.6, it's bouncing around depending upon if it's starting to warm up or it's right on the edge there. Yeah, 0.6. So primary windings are the same, okay? Pretty much as this. Well, here's where it gets a little bit different on waste spark. Waste spark is a different type of coil. It is basically 2 coils that are wired in series. So this winding comes all the way down. This secondary winding comes all the way down. And comes all the way over to the other side. So, okay, well, that's the part that it makes sparks out of the secondary windings, and that's going to have a lot of windings. These are going to be very, very fine, and there's going to be a bunch of windings. So how am I going to ohm that out? Well, I have to ohm it out from one terminal to another terminal. Now, if you go back to the last coil we had a single coil. We had a single coil right here. I don't know if you remember what this thing ohmed out to. It was about 7,000 to 8,000 ohms is what these secondary windings. How much resistance do you think it'd be if we wired 2 of these in series? Well, let's go see what this gets, okay? So if I put 2 coil secondary windings in series, I would expect to get, in the case we have here, looks like about almost 14,000 ohms, 13.77 K ohms. Hey, guess what? That's exactly about the same as 2 of these coils. And that is the typical specification for what we call a waste spark coil system. So how this system works is spark jumps out of one side, goes all the way through the plug wire, jumps all the way down from the center electrode to the ground electrode of that spark plug. Then it goes into the ground of the spark plug, travels through the engine block ground, all the way over to the opposite spark plug, comes through there, goes through the ground electrode, jumps up from that ground electrode to the center electrode, and returns back to the coil. These are like little batteries, think of it. Whatever has to come out has to come back. And in this system, it comes back through the other side. And because it's a series circuit, when you lose one side on here, a lot of times you'll have two cylinders will die on this thing because it doesn't put sparks out on either side. Now, just like any other coil, we check the primary, we check the secondary. We also got to make sure that it is not grounded to the case. And in this case, we checked from the secondary windings to the case, and it's OL, so it's at least not grounded to the case. And I'll flip it over and we'll do the other side, and we'll check the other secondary winding, and just make sure we don't have a bad coil here. Have half of it, and this side comes out to 13.64, so hey, that's a good coil. Not a bad deal. Okay, so we got that coil out of the way. Well, here's another one style that we have. Hey, waste spark again. Now, I hope you're ready for it this time. How many coils are in front of you? Well, one coil pack, but how many coils are inside of it? If your answer is 3, you're getting a hang of it. Again, 1, 2, 3, and the third one over there. Well, now when we go look at the wires that go operate this, there's 4 wires. Why is there 4 wires? Well, I got 3 coils. Okay, I need 1 common power and 3 individual grounds. So in this one, unfortunately, all our other coils, they kind of told us where positive was, but on these they don't. So I either got to figure it out through ohming stuff out, or I can look at the wiring diagram and figure out which one is positive. Typically it's 1 on the end on these, whereas the other coil was in the center. It's counterintuitive, but so I'll give it a shot here. Either it's going to be OL, or it's going to have a normal coil would have probably about half an ohm resistance in it. So let's see how I guessed here. Did I guess right? Hey, it looks like I guessed right. Okay, I've got 0.5 ohms resistance. Hey, my primary winding looks like it's okay on that particular coil. So that would be the one on the right. Now I'll go to the one in the center. And we look at that one, and that one ohms out at 0.6 as well. Looks good. And then I'm going to ohm out last, and that also comes to 0.6, and that is also good. So these coils are all checking out okay. Now the last style that we're going to have is we're going to have coil on plug. And let's see if I got a coil on plug set up here. Dig in my box of goodies. Here we go. And last but not least, we've got our 2-wire coil on plug. So our 2-wire coil on plug is same as any other style coil. It's a smaller version of this, except we've got the plug wire built into it. So as we pop this off, this is what it looks like when you pop the boot off. Instead of having a plug wire, we have a little resistance wire on the inside. This is to stop a little radio noise that comes over from a solid wire. We put a little resistance in it. And just like any other coil, it's going to have a primary winding and it's going to have a secondary winding. So let's ohm this coil out, and then we'll see what we get. So why did we go to individual coils? Well, it's pretty simple. It gives it a long time between firing cycles to give that coil a time to recharge. So when we go look at this coil, this one, let's see what we're getting for a resistance. Very similar to our other coils. It's a smaller coil, but it looks like it's got about 0.6 ohms primary resistance. So now we're going to go back and we'll check secondary resistance on this. And a little less, okay, we hooked this all up in here, a little less than there, but I think this is well within specs. We got 5.34K, we got 5,000 ohms resistance, and that includes wire. So anyway, and I could again check this thing to see if it's grounded anywhere, and it is OL to the side, so there's nothing going on there. So this coil should work. It should work. So that is basic coil checking, resistance checking, resistance checking the primary, resistance checking the secondary, and checking for any shorts to ground. Now, there are other coil checks that we'll be doing on the vehicles, maximum output tests that we have using IDS, and actually measuring the waveform to go find out if this coil is shorted in the windings, if it's got winding problems, which many of these have. And I know a lot of guys are just swapping coils out, and that's a quick way, but it finds the obviously bad ones, but it doesn't find all the bad ones. And we'll look at those tests a little bit later.